So with this, as you know that first we need to get the concept called so yeah, so you know this different ionic strength and same dielectric constant as 40, 25, 81. So the corresponding relative magnitude of dy equals q length, that you know that 1 by k is called dy length, and k itself is centimeter inverse. So k inverse is basically giving the centimeter inverse of inverse, which is nothing but the length, and this is proportional to epsilon r, right? So to the power half, so root over half epsilon r. So from there you can calculate these different ratios of this dy length, k in k1 inverse, k2 inverse, and k3 inverse. That is equal to root 4 is to root over 25, is to root over 81. So it's coming around 2 is to 5 is to 9. So from there you can calculate the ratio for this dy length. And in the second question we have talked about that we have two vapor pressure and two ethanol and methanol, and they have a for 100% ethanol methanol this vapor pressure is given, but in the solution phase there will be some mole fraction of that you have to calculate, and from there you can get the idea of total vapor pressure from Raoult's law. As you know that total vapor pressure is the vapor pressure contribution from this ethanol as well as methanol. So from there you can get the value of P0 xc plus P0 PM0 xm. So these two are the mole fraction xc and xm for this ethanol and methanol respectively, and from there you can get the value of total pressure. So now I will take you to this question third. Now we will go to the question 4, where we need to find the vapor pressure of 2 propanol, which has this vapor pressure uh, 50 kilopascal at 338.8 degrees Celsius, and after that but it fell to 49.62 kilopascal when 8.69 gram of an individual organic compound was dissolved in 250 gram of 2 propanol. Now I need to find out the molar mass of the compound. That is very good. So now x solvent, what is the mole fraction of solvent, right? You have to find out, and this is basically p by phi0, that is the vapor reduced vapor pressure, like yes. So that is the ratio for this vapor pressure of pure solvent as well as the solvent now. So 49.62 by 50. So you have some vapor pressure decrease, that means there is some concentration of this inorganic volatile compound also, that you can calculate by the fact that you need to get this value of this total fractions, right? Mole fraction. So XA solvent is phi by phi0, 49.62 by 550.00 equal to 0.9924, and from there Ma equal to C3H8O, that is 60.0, sorry, yeah, 60.0096, and you can get the value of yeah. So you know this mole is nothing but 250 gram by 60.096 gram per mole. So this is coming around 4.16 mole, right? And Xa equal to Na by Na plus Nv. Na plus Nv is what? Na plus Nv is Na by Xa, right? Because you have the less mole fraction moles of this B. So as a result you are getting this Nv equal to 4.16, 1 by 0.9924 minus 1, right? That is equal to 3.816 into 10 to the power minus 2. So like this you will get this molecular weight of B also, which is coming around 8.69 gram by 3.186 into 10 to the minus 2 mole, so overall 273 gram per mole. With this, so you know this MB is 8.69 gram by 3.186 into the minus 2 mole, so it's coming around mole in the gram into mole in by 273. So that is the molecular weight of this dissolved in volatile organic compound. Now coming to this question 5, where you have to calculate the mean ionic activity coefficient activity of a solution, that is 0.020 mole kg inverse. So this is a mole per kg, right? So this is nothing but this molal, right? Molal. So this is 0.0220 and 0.035 mole per kg, and you need to find out this mean activity coefficient activity of solution. That is, this is extremely important, and people used to ask this question for CSI and NetGate also. Just think about it for some time. this log gamma plus minus, that is the mean ionic activity coefficient. This is minus z plus z minus a root over I, right? I is the mean what I'll call this is the ionic strength of the solution, right? And I is summation of half summation of I z I square pi into with it, right? So this is the xi z, this is the mole fraction, right? What is called this z I xi, right? This is the mole fraction, molarity, right? Z m I square, m some half m I square, right? Z I square. So from there, you know, this charge for this initial sodium and chloride both has this plus 1 charge, calcium 2 plus and nitrate minus, right? So like this way you can get 0.215, right? One is for sodium, this one is for this chloride, and this is for nitrate, and this is for your calcium, right? So from there you can get the ionic strength I 0.125. This is unitless parameter. Uh, this is not unitless parameter, so this is basically mole per kg, right? Ionic strength. Now you know this gamma plus minus, so minus 1 into 1 into 0.503 into root over this half values, right? 0. This is around 25 to 27 degree standard. This is 0.509. So from there you know this gamma plus log gamma plus minus is equal to minus 0.17996. So for NaCl you know this 0.661 for NaCl gamma mean ionic activity coefficient, activity of the solution, right? So this one and this 0.661. So you can get the idea of this mean, how to calculate this mean ionic activity coefficient, and from there you can do many other things, that how basically this can be taken forward. Now come to the next question, where you need to find out the mean activity coefficient of KCl in 3 dilute aqueous solutions at 25 degrees Celsius are 0.927. These are the mean activity coefficient at 5 molar molal, and 0.902 at 10 molar, and 0.816 and 50 molar, right? Molar, this millimole per kg. Estimate the value of B in the extended device local law. This is very important, and this is very important long questions. So you know this solution for B is minus. So this is the extended Debye law, where log gamma plus minus equal to minus a z plus z minus into root over I half. So 1 plus b I to the power half. This is the value for this gamma plus minus, and from there if you make a solution for b, that is equal to minus 1 by root over I plus a z plus z minus by log of gamma plus minus equal to minus 1 by b0 half plus 0 point. So if you do calculation, so you are getting this b value around 1.3, right? So like this way you have to do this equation, this one. So you understand that from the previously we are doing this, that what was your first question. So your first question just what is Raoult's law. So to explain this Raoult's law, to get this for ideal solution, this pressure can be done in the terms of Raoult's law. Then we are basically calculating this mole fraction and total vapor pressure, and then by using Raoult's law and Dalton's law, and after that with this we are going to take this Debye screen length, where you will get the 3 solutions, and root over 4, root over 25, root over 81, and then we calculate this molar mass of the compound, and then mean activity ionic coefficient. Then we got to know the value of this B in the extended Debye law equation. So you understand that how this electrochemistry field was evolving with time, where you can do multiple things in respective of their time, right? But one thing is that for ideal solution, it is coming to for real solution. So for that case you need to do a lot of correction parameters. So B is one of the them, that is called the size parameter corrections. This B, that is in Debye limiting law, and in this correction you can do multiple correction actually. So here is this only B which has the same what I will say, which has the same unit of this root of the square root of ionic strength, right? So that's why you are getting this B value. So this is B value is size parameter. So for a real solution, so there will be many things will be there, because this for ideal solution this is very diluted, so effect of other ion will not be there. But for real solution there will be a lot of things are there. So that's why we need to give some correction parameter to it, and based on that you can calculate the value for this, what I will say, the value for the for this real solution. So we have another some questions, we will take that, and so in course of taking of this question, just refresh your mind how we can proceed for the next questions.